Hey, it's Abdul. Welcome to the very first video of the BIOSTATS CRUSH course. Today, we're going to be going over the measures of central tendency. Now, just a heads up, because this topic is super basic, there are going to be no solved questions for this session. Now, jumping into the basic core concept of measures of central tendency, it's important to note that data is very chaotic and very messy. Now, the branch of mathematics that tries to make sense of this madness is known as descriptive statistics. Now, descriptive statistics have really two very important mathematical measures that help in doing so, and that's going to be the measures of central tendency and the measures of dispersion. The measures of dispersion is going to be covered in a later video, but today we're going to be focusing on the measures of central tendency, which is going to be stuff like the mean and the median and the mode. Now, what a measure of central tendency tells us, it tells us how our data is clustered, and also, very importantly, it tells us if our data has any significant outliers that might be affecting the way how our data is clustered. Now, there are three important measures of central tendency: the mean, the mode, and the median. Now, if you're watching this and you're like, hey, I'm pretty sure I've taken this before back in middle school, you're absolutely correct. But we always have to start from somewhere, and these basic measures are still a core foundation of everything that is biostatistics. Now, the mean is the arithmetic average of your data set. And in plain terms, this means you add everything up within your data and you divide it by your sample size. Pretty simple. One thing to note, though, that the mean is the most sensitive measure of central tendency to the effect of outliers. So if your data has an outlier, the mean is going to be affected the most. Moving on to the median really is like the middle child of these measures of central tendency. It is, simply put, the middle number of your data set when you organize it by order of magnitude. Take all your data set, organize it from lowest to largest, and then find that middle number, and that's going to be your median. Now, the median is less resistant to the effect of outliers compared to the mean, but it's also more sensitive compared to the mode. So it's kind of sitting right down there at the middle. And then we have the mode. The mode is the most frequent value in your data set. It's the most often seen value. Now, the mode is the most resistant to the effect of outliers compared to the median and the mean. So these are the three core measures of central tendency that tells you how your data is clustered when doing descriptive statistics. Now, there's something that's very important, and that is that life in general likes to cluster around a singular point. We call this the normal distribution or the Gaussian distribution. Now, this little kind of picture shows you, it's like a little tinker toy, and it shows you how if you drop those beads, it tends to fall within this kind of normal distribution where it's clustered around a single point and expands kind of in a very beautiful and symmetric way. This is the classic picture of a normally distributed curve, and you will notice that in a normally distributed curve, the mean, the median, and the mode are all exactly the same. However, life is not always normal. This is where we are introduced to the idea of outliers and skew. What skewed data means is any data that does not follow a normal distribution. It doesn't have that perfect symmetric bell curve, and the data is kind of skewed towards a direction, either to the right or to the left. And this is usually due to the effect of outliers, but can also happen in general if something is not normally distributed. Now, this is an example of skewed data. You can see it's not that perfect symmetric shape, but a very common question that the MBME loves to ask is, how do I tell if it's a positive or a negative skew? Well, a quick tip to kind of quickly figure that out is to look at the tail and look at which direction the tail end of the graph is going. If the tail end is going towards the right, that is known as a positive skew, and if it's heading towards the left, this long tail, this is known as a negative skew. Now, earlier I mentioned how that in normally distributed data, the mean, the median, and the mode are all equally the same. This is not true for skewed data. the mean, the mode, and median are different in data which has a bit of skewage. Now, when you look at a positively skewed data, where the tail is going towards the right, you will notice that the mean is going to be the largest value. And that's because the mean is the most sensitive. It is dragged, if it's a positive skew, it is dragged more positive than others. The median is somewhere towards the middle, and the mode is the one that is least affected by the presence of outliers, so it's usually the smaller number. And it's the same thing if the data is negatively skewed. The mean is going to be the smaller number because it's being dragged towards the negative side. The median is always on the middle. It's that baseline, kind of like stable middle child. And then you have the mode, which again is the least affected. And that's the basic core concepts of the measures of central tendency. Looking at how this applies in practice, you will know as a general tip and trick, whenever you're reading a paper and you see the data is reported as a median instead of a mean, we know that we are most probably dealing with non-normally distributed data. So if a data is normally distributed, they will usually give it as a mean. And if it's not normally distributed, they'll give it as a median. And look at this table, for example. They mention this here in the statistical analysis that continuous parametric data, so parametric means normally distributed, will be reported as a mean and standard deviation, whilst non-parametric data will be given as a median and interquartile range. And this is the same thing when you look at the baseline characteristics of the study. You could see that in orange, these are all normally distributed data because they're giving it as a mean. However, you see the GCS score down in the bottom in pink is actually given as a median. So I automatically know when I'm reading this paper that this means that the Glasgow Coma score was non-normally distributed. Could this be due to an outlier? Probably, but could also be just to the natural distribution of data. And this means that some of the tests that we do that requires an assumption that our data is normally distributed cannot be used for this GCS score. And just like that, we are now done with measures of central tendency. I hope you guys found this video quite helpful, and join us next time as we go through the measures of dispersion. If you did enjoy this video, please leave a like, subscribe, comment if you have any questions, and hit that bell icon so you can get notified the moment I drop another video. If you're interested in mentoring, specifically for step 2 or step 1, then you could use code KLED, that is KLED, for 20% off for the first 5 people who use the code. Thank you so much for listening and wishing you a beautiful day.